only very recently actually. And he wasn't only interested in machine translation, and he wrote one of the very first books on machine translation. He was a very important person in machine translation. But he also saw that machine translation is not only about applying computational techniques or automatic translation techniques for Cold War purposes, but machine translation has to do with linguistic problems. You have to make concordancies, you have to make frequency lists, you have to do lemmatization. So you actually do linguistic research to enhance your machine translation. And he sort of singled out these linguistic research topics and gave it to students of him who did, in the 1950s, not only machine translation, but did stylometrics with it, and used all these frequency list lemmatization concordances for instance, for author attributorship. And stylistics and author attributorship are, at the moment, two big fields in digital humanities. Right? So it all started with a failure on the part of the war, which ended before the computers were finished. What do we do with the computers? Some clever people who thought we can not only crunch numbers, but we can only use them for humanities subjects like machine translation. And then somebody like Andrew Donald Booth, who said, well, machine translation, it's all about linguistics, and we can single it out further and actually do apply linguistics and actually literary studies, textual studies with it. So that's one bit, machine translation. There was another person you may have come across in your readings or in your lectures, that's Roberto Busa. He was an Italian Jesuit, and he is actually by the digital humanities community generally seen as the father of digital humanities, although I claim that Andrew Donald Booth was the father of digital humanities. But I mean, it's not a battle of first, it's but still, Andrew Donald Booth is my number one for digital humanities community. Roberto Busa is the number one. What Roberto did was, and I can say Roberto because I know him, I knew him because he died a couple of years ago. What he as a young scholar in the late 40s, and he was there in the war, and he knew about this machine translation stuff and cryptanalysis, and what he was thinking of was how he could use computation techniques to make his life and his work easier. Roberto Busa was, his main theme in research was the complete works of Thomas Aquinas. And the complete works of Thomas Aquinas are big, are huge. And he wrote a PhD on some stylistics in the complete works of Thomas Aquinas. And his PhD he did sort of by hand, like people did in the 1940s. So he read the whole complete works, and he jotted down on small cards every single sentence in which the word "in" was used, because his PhD was about the use of "in" in the works of Thomas Aquinas. And he assembled like 10,000 of these cards, and he rearranged them, and he wrote his thesis about them. And he thought, well, we can't keep on going we can't keep on working with these file cards, 10,000 of them, and these huge texts. We should be able to do it with computational power. And he started to think about it, and he started to talk to IBM people about it, and the IBM people said, well, we can't do it now. The computer is not for doing text analysis, it's for numbers. And he hooked up with people from machine translation, and a whole sort of synergy was created, and he actually managed to use computers in the early 50s, managed to use computers to do what he wanted to do. That is, encoding categories of vocabulary during input. So that's actually lemmatization of every single word or words he was interested in during the input phase, during the phase that he wanted to input the text into the computer. And the input of the text on the computer was done with punch cards. I don't know if you've ever seen a punch card. That's a cardboard card with holes in it. right? And the position of the holes, it was standardized. The position of the holes was read by a reading device, which was then hooked onto the computer, and this could translate language into binary code for the computer, and then you could add a program, say do this with it, and outcome came an answer. The punch cards, which were punched for the complete works of Thomas Aquinas, weighed 500 tons. And that's 500,000 kilograms of punch cards. I didn't want to be the one who had to enter everything in the computer. Actually, another great scholar who died, a Canadian scholar, Paul Fortier, he told me once that at night, if they could use the computer, it was in the 60s, they could use the computer of the mathematics department or the science department at night. The humanists could use it at night, you know, when all the scientists were asleep or were having drinks. So they walked over with their punch cards to the computer. They inserted all the cards. It took them 4 hours to insert all the cards. They wanted to do text analysis of a great text. I don't know if it was Shakespeare or something else. So they inputted everything. They pushed the button, and the computer said no. Because they had forgotten to actually program that the computer had to print the answer. So the answer was calculated, but just in the computer's brain, and the computer didn't spit anything out. So they were 4 hours of work for nothing. If you see in museum, sometimes they do exist computing museum for computing, history of computing. When you see stacks of punch cards, you will always see that there's a cross on them. There's like in filled pen, there's a cross on them. That's because if you let them fall and they're all out of order, the cross is your guide to actually reassemble them. That's the tricks they all used. There you go. That's something I found. That's actually what Paul Fortier told me. You know, you spend hours to program by hand, then you manually set them to the mainframe. You run the program, and then the computer says no because you forgot something. That was, you know, the delights of computing at that time. These two things are really important. We have machine translation on the one hand, Warren Beaver, you know, for Cold War purposes, Andrew Donald Booth, who saw the opportunities for humanities subjects, and then you have Roberto Bursa, who actually did lexical electronic text analysis. These are two fields which sort of formed itself in the very early beginnings of the humanities computing, or the use of computers in the humanities. It's machine translation and electronic text analysis. Machine translation was discontinued as an official US task, was discontinued in 1966 by the US government. They didn't want to put any money anymore into these machine translation programs because they were not very successful, actually. And a lot of scientists had to be paid to make all these programs, had to work on algorithms to do that, and they were not very, very successful. And in 1966, the US government said, look, we're going to stop this program, and all the people who work in machine translation, we're not going to dismiss them, but we're going to sort of reorient them into computational linguistics, because it's all about linguistics. And that's the point, 1966, where computational linguistics as a field came into being. Electronic text analysis, on the other hand, sort of migrated, morphed into what we know as humanities computing and now digital humanities. And that's actually the reason why when you go to digital humanities conferences, or when you read books on digital humanities, or you study digital humanities, that most of the times it has nothing to do with computational linguistics. That's a field on its own, because it comes from a different start, and it's, there's a whole community, the computational linguistics community. There's tens of thousands of people doing computational linguistics in the world, and they don't feel to be part of the digital humanities movement, which we are in, and that's mainly the reason why. That's why. So humanities computing. I told you that these gates of hell, this sculpture for me was a metaphor of humanities computing, both of how humanities computing were interlinked and also how failure was very important point in time for the formation of humanities computing. But that's where you could recognize actually the gates of hell, even if you've never seen them. What Auguste Rodin did after he had created this gate was not put this gate on an exhibit, because during his lifetime this gate was never exhibited because it was owned by the state. The state of France had paid for it, and he couldn't claim it, he couldn't sell it, he couldn't do anything with it. It was sort of, put away because it belonged to the state. And Rodin said, hey, wait a minute, but I need some money, I need to live. And he put in a bid or a proposal to put it on exhibit for the 1900 World Exhibition in Paris. And it was denied, he couldn't do that. The French state government said, no, we're not going to do that. Probably because they didn't want to be confronted with the failure of making this museum. So what Rodin did was, he said, okay, I will take a couple of the statues or a couple of the figures of my gate and blow them up and make them into statues. And that's how we know the thinker, Le Penseur, the one over there. He is actually very central in the gate over there, you see. That's the same one. But he enlarged it and he could sell it as a statue. There's not one Penseur, there's 6 or 7 of them made from the same cast. The 3 figures on the top are also a separate sculpture, became a separate sculpture. And there's other figures like Ling Man, which are all over the gate. And also, this also is for me sort of metaphor, because what had become humanities computing was sort of an amalgamation of applications of computation techniques in the humanities, but a bunch of people were interested in author attributorship, singled that out and made it into their own discipline, made it into their own statue, and made a journal about it, or made conferences about it, and all that. Somebody else was interested in stylometrics and did this. Somebody else was interested in text encoding and founded an organization on text encoding and conferences on text encoding. So humanities computing is a big thing, but it also it contains of different sort of sub-disciplines, and that was also a metaphor for me. But I told you that the gates of hell were never exhibited during the life of Rodin. When he was denied his proposal was not honored to put this on display in the world exhibit, he said, okay, I'll do my own thing. And what he did was he made a second sculpture, Gates of Hell. That's a plaster sculpture. And you see there's a difference between the two. The bronze one, which was never on exhibit during the life of Rodin, has a lot of detail, a lot of statues, a lot of figures, whereas the plaster one still has the thinker and the 3 persons on top, and the tympanum is still intact. But the 2 leaves here are blank. All the figures are gone. They're away. It was partly out of protest he did that, but also partly because as a sculptor he had moved on, and he wanted to create a sort of abstract piece of art. And this is, by some art historians, this is seen as the first real piece of abstract art. What he did was he created the same thing as the Gates of Hell, but he changed it. He left more place there for illusion. He left more room for interpretation. You couldn't say, it's about this or that, because it was blank, it was missing. There was only shadows and only sort of indents there. It's still not a door, because it doesn't have an opening mechanism. It's still a piece of art, but he changed it. And it was this plaster gate of hell, which was on exhibit in the sort of private version of the world exhibit he did as a protest.